How many of you are familiar with the phrase, a universal engineer? I myself was not very familiar with this phrase until somewhere around last year. On that note, good evening to everyone. I wish to warmly welcome you all to the Introduction to Chemical and Process Engineering, an introductory session organized by the 18 batch of the Department of Chemical and Process Engineering. So I want to start off by telling a small personal story. Now, when I entered university and somewhere around last year, I really personally, I did not have a big idea as to what field to choose or what specialization to go for after my first semester ended. Now, I know some of you can't relate to this. I know some of you can relate to this. I know some of you will already have an idea of what specialization you want to do as an engineering student. I mean, we have all worked very hard to come to this place. We have all worked very hard to come to this university. And some of us have, let's say, an ambition to enter a field and to build a career in some specific field. But some of us do not. And we are all today, I think you are all facing a very important and critical decision in your life. And I know that the 19 batch brothers and sisters, you all will relate because you all are facing an important life decision. Now, not to put any pressure on you, but we all know that this decision will be a life-changing one. And you will decide and build your entire career based on what engineering field you choose to specialize in. So we want to recognize that this is a critical decision. And a critical decision such as this should always be a well-informed decision. So that's why we, the batch 18, thought we would organize a session like this to give you some insights, to give you some knowledge. At least if you can make a decision, I know that decision is truly up to you. That decision is up to you, what field you want to go into, what sort kind of career you want to build for yourself. But a decision such as this will always be a better decision if it's a well-informed decision. And I think why we, the Department of Chemical and Process Engineering, want to do this session is chemical and process engineering, when compared to other fields, is not as much of a household name as the other fields. I am sure you would agree. Because when you were small, you would always have heard of mechanical engineers, you would have heard of civil engineers. These aspects, these fields are not strange fields to you. You all would have all heard of this. But the field of chemical and process engineering is kind of an enigma. It's kind of something that you don't really know that much about. I personally thought it was related to chemistry. And I thought it was purely chemistry. I didn't understand the differences from doing a chemistry degree and from doing a degree in chemical engineering. And I have come to realize the differences and the scope of chemical engineering only after my field familiarization session. And I know that due to the situation of the country, the unfortunate situation of the country and the world today, some of you may not have got a chance to attend your field familiarization session. And as such, you might not have a proper understanding of what the departments have to offer and what sort of careers you can build. So it's always, so I think this session will be very useful for you. Whether you have attended or whether you have not, you still might have doubts to clear or questions that you can ask and get clarified, or simply more things you can, if you were just curious to learn more about chemical engineering, then you're welcome here too. So I hope today will be a fruitful session. We have organized this for you, and there are so many, and the professors here, the lecturers here, they have taken time out of their busy schedule, and they have stayed, and they're doing this for you. We have organized this for you. So I hope you will take the best out of this session. Please interact with us, and I will shortly explain to you how we are going to do today's proceedings. So again, on a very warm note, I warmly welcome all of you all to today's session. Please interact with us, please pay attention, please ask questions, and we hope that you will all learn something today. So today's proceedings will be as follows. I will invite the three speakers of today, I will introduce them, and they will all have a small session of their own. After those sessions are over, we will go into a panel discussion. That panel discussion will be moderated by me first, where I have handpicked some frequently asked questions, I think, which will help you understand more about this field and will better inform you of the choices that you will be making. After that, I will also give you some time to ask questions. So please, when the panel discussion begins, I will tell you the time, and then you can direct your questions through the Zoom link, the chat, and through that, I can direct your questions to the lecturers, or you can, even better, I would recommend if you could just unmute your mics and speak directly to the lecturers themselves. But we will come to that. And I think now we can start today's session. Please pay attention, and please, I hope you will enjoy and interact and learn something new today. So to introduce our very first speaker for today, he is a very special individual, and he has been a lecturer of mine too. Professor Ajith De Alwis is a senior professor at the Department of Chemical and Process Engineering at the University of Moratuwa. He has completed his PhD at the University of Cambridge, UK, and his BSc Engineering degree at the University of Moratuwa. He is the recipient of numerous awards in recognition of his work, and a man who holds a vast amount of knowledge and unparalleled experience in the chemical and process industry in Sri Lanka. He has both participated in and led numerous high-profile projects and research teams in Sri Lanka during the past few years, and is a respected member of many major local and international professional bodies. Professor Ajith also currently serves as the project director at the Coordinating Secretariat of Science, Technology, and Innovation, Sri Lanka. Those of you who will be joining the Department of Chemical and Process Engineering will be meeting Professor Ajith in the second semester as your Process Engineering Fundamentals lecturer. He is a true enthusiast of this industry who is always willing to help you in any way he can and answer any doubts you may have with regard to this field. Sir, it is time for you to take over. Over to you, sir.
Thank you. Indeed interesting to join from home, but an excellent initiative from the batch on behalf of the incoming group. I understand the reason. You all need to know about your selection, future selection, and it's my pleasant task to help you out in some way. You see, it's always when you select an engineering field, you need to explore. But of course, some of you may really come up in life with an interest. Okay, I must be this person. I must do some specific field because you may have heard somebody's exploits. You may have a hero in your life. So it's always interesting. But sometimes we feel that in Sri Lanka, we really do not have a solid understanding of some of the fields because our economy has not really projected a field of this nature. I usually say Sri Lanka is developing because we do not have chemical engineers or chemical industry, chemical engineering, that interface. Now, I don't want to say that everybody should be a chemical engineer and that is the best field, and no such thing. But this is a very, very important field where we can contribute a lot. So with that, what I hope is that we will keep interacting and you will have your questions, but I thought I will share a few slides just to excite you, to tell you a few things about the spread, the vastness of the chemical and process engineering. And that's very important. And we all say that chemical engineering, and you heard the term universal engineering. You Google, you will find it. It's been is the name given because of its breadth and the depth. So we really have a field which is not as old as the other fields like civil engineering. We always tell civil engineering is the first engineering field that came out of military engineering. The word civil came because you took the uniform away and you were wearing civilian clothes, and they were the engineers who did everything. And with time, we understand that you have a lot of specializations need to happen because we just simply, there's too much to do, and if everybody start doing everything, that's not possible. Whereas chemical engineering similarly evolved with areas like chemistry and mechanical engineering. If you take the case of Germany, they identify, look, you can't do this. You can't get a chemist to do some reaction and mechanical engineer to do a plant. That's not going to, it's a recipe for disaster. And then the chemical engineering field evolved. And in USA, where the field actually thrived at a very initial stage, they went in with purely the industrial development from the chemistry upwards, the chemical engineering came. And I will give a couple of examples, but this field happened in United Kingdom as with Industrial Revolution. So let me switch off my video and I will share some slides and I will reconnect again. What is important is you ask very the questions that comes to your mind, and why do you select this? Why should I be doing something else? And how do we work? Because at the end of the day, once we come out of the university, the success depends on working together. Not I as a chemical engineer saying, okay, no. I must work in chemical engineering. I must work with my fellow chemical engineers and no one else. No way. The society thrives, society develops because we have to work together. And that is a key thing. And even in universities, I think if you study well, study together, research and research teams together, we will really develop. And that's something we look forward to when we encourage students to come into the department. We hope that we will interact and not just think about just one area. Because as an undergraduate, you really need to develop your fundamentals. And so it's not just about chemical engineering, it's about being an engineering fundamentals. So it's very important. So let me take very quickly, share screen after switching my video. Can you see the screen?
Yes, sir, we can.
Right. Now this is, so chemical engineering, as I mentioned, evolved recently. Of course, now when you say recently, we have celebrated our 100 years and we have done a fair amount of contribution to the development of the society. And one thing I like to mention from a chemical engineering point of view, what is chemical engineering? It's, we all deal with processes. And that's probably the reason we have come up with taking the word chemical and adding process into our field, because the life is all about processes, right? You can, if you think, you can have 4 types of processes in this world and no more and no less, right? We have physical processes, something physical happening, something chemical happening, something biological happening, and we also have the 4th one, something nuclear, which of course crosses matter and energy. And chemical engineering deals with all these 4 processes. And that's why this is a field with breadth. And depth, of course, comes with how you work in a particular sector. We are the first engineering group that embraced biology. And as I said, it's the biological processes, and our unique contribution, which still stays and supports the world, is penicillin. So that actually started biochemical engineering. And today we have biotechnology. So if you take biotechnology, it's a 3-legged stool with like molecular biology, biochemistry, and chemical engineering. That's the European definition of biochemical and biotechnology, right? So we have these various specializations have come out, and we all working towards giving results to the society and doing things in large scale. Because as I to tell, if you have a headache, if you want a paracetamol, and the paracetamol is of like 100 rupees a paracetamol, your headache is not going to disappear. So we have to produce it, everything in large scale, right? If you want to serve the society. And all what we do and our profession is basically about scaling up. And that is a unique problem that we faced in Sri Lanka. So far, we have not exactly understood this need for scaling up and have not attempted scaling up, right? So we, in our undergraduate, in our program, we try to get to this habit of, to the true understanding of a development of an industrial process. And it can be a biological process, it can be a nuclear process. We will have a standard chemical processes, and it can be even a physical operation, right? So all 4 processes, how do you turn out an industry and be successful, is the base of chemical engineering. And in that format, we interact with all the others because we can automate the factory. We can use robotics. Actually, robotics developed with chemical industry because the environments were hazardous and dangerous. So one of the first applications really were in chemical industry. So we bring, when you say digitalization, we talk about automating factories. I mean, that's how things have started with process control. So all our plants, we actually don't rely on manual systems. We are on automation. So digitalization is, we have been working with it as it evolves. We have been benefiting as well as we have been contributing to the process of development. So in a nutshell, it's all about industry. And precisely why Sri Lanka is developing, because we do not have an industry to be proud of. That's something that we need to work on. So if I to give a small definition, some of you may heard of Glenn T. Seaborg, who is a Nobel laureate. He not only won once, he won the Nobel Prize twice. So he kind of says this sentence about chemical engineering, and we can bring so many examples of this nature, but I just thought this is a very basic statement. We should recognize that it is a chemical engineer who converts discoveries into commercial realities. So whenever you have a commercial laboratory finding, I have this process, I need to scale it up, I need to get it to commerce, chemical engineering is at the heart of it. So he has given us the means to acquire our present abundant wealth of chemical materials. Without him, we would not have our plastics, resins, high-octane fuels, and so on. So the chemical engineer has a special satisfaction of seeing his work end in an actual productive application. So we actually are responsible for this transformation of the society. Actually, the 4th industrial, not the industry 4 I'm referring to, but if you look at from a traditional industrial revolutions, the mass production concepts happened with chemical engineering. So after the war and even during the war, there are so many things that happened. and the mass production, that economy is dramatically changed subsequently as a result of process engineering. We may not always acknowledge that, we may not have seen it, but it's true. And some of those principles, we are evolving with time. And so today we have some special additional problems and issues, but we believe and we understand chemical engineering is still again at the heart of it, because we have to understand, and that's your task as an undergraduate if you come to this field, we need to understand how do you transform something, how do you transform a raw material or an idea into a commercial success. Of course, success parts comes from understanding leadership and management, but to the commerce side of it. So that's truly the domain of chemical engineering. And why universal? So it's kind of at the heart, and this can be very interesting discussions in Sri Lanka specifically, because you never hear. And sometimes we even now have tuition in field selection, right? So I suppose you hear something completely different. And of course, that is because of our nature of economy. And so I think we can take on these questions. You can see the center, you can see the fundamental sciences, then you have the applied sciences, then you have certain supporting infrastructure engineering, as I say, and then coming together to do this transformation, because that's the end point for the society. And I will take few examples to in this. Let me take now. So we have these diverse vistas actually. If you look at a distance horizon, distance vision for chemical engineering, now I just took about last few months Chemical Engineering Progress magazine that comes from US, from the American Institute of Chemical Engineers. By the way, if you join the department, we all expect our students. So we have a AICHE student group in the department, so that we hope networking from day one happens with that group. That's a push that we try to do, work with the students. So you can see microbiome engineering, right? And molecular analysis, battery energy storage. And for that, if I to tell last year's Nobel laureate from Japan, Akira Yoshino, whom we know about the lithium battery, his origin comes from chemical industry, chemical engineering, and also from the Asahi Chemical Company. Battery storage is chemical storage, and it's all about processes. And batteries are very, very important in this 21st century. So you can see process intensification, vertical farming, and in this we bring artificial intelligence. Of course, then we work together in this area, not by ourselves. So we pool resources, food engineering, and in climate change, some of the answers are seriously in the process engineering domain for climate resilient economies. And you can see a big one in pharmaceutical manufacturing. It's a key area that in Sri Lanka right now, we are hoping for about 25 manufacturing pharma factories to come up in Sri Lanka. And we are also pushing for very seriously biotechnology. You will seriously shortly hear on that. So you can see the diversity in this field. I just took about 8 magazines and put the front page for you. So this diversity and shows the breadth again. But most of you, all of us basically won't go into each and everything, but we get a very sound footing, sound basis to tackle the breadth. And some of you and always will go into 1 or 2 areas in depth. So we cross all 4 sciences, like from the maths to the physics to the chemistry and biology. The day the chemical engineering was very closely associated only with chemistry is over. Today we are connected with biology. We are very much with physics. I'll give you 2 examples on that. And but we have the basics on the chemistry too. I mean, we are the only first engineering field to embrace all 4 sciences, and we still are on that. And of course, economics is a guiding principle, because as engineers, economics are very important. Why we do, and our receptivity by the society level is only if we produce things that are economical to people. So we have to understand the economics. So you can see, you can get a very good idea about this from this. So here I just again want to stress, now in ourselves, we call it chemical and process engineering, but you can cross from Singapore to US to Canada to UK. I just want to show that biological processes and physical processes are nuclear. You can see if you take the University of Leeds, it's chemical and nuclear engineering, and you will have it in US also, the department named as chemical and nuclear engineering. And today, most of the time, you will see departments named as chemical and biomolecular engineering, right? You can see two examples of Notre Dame and Rice, but you will go into MIT. I'll take an example of MIT, which is the number one chemical engineering department in the world. So you will find now, so you can see the bio end to the nuclear end. And we have the traditional typical chemical processes in between. And all of these will do that. But what happens is we never study a particular product. We don't study a raw material. That's not our system. We understand how to convert something to another. And from thermodynamics to kinetics to the economics to calculations. So we should have the strength in converting something to a worthwhile thing. And today, increasingly, we need to understand from the environmental point, and chemical engineering plays a big role in the circular economy, that is the 21st century economic principle of recycling and upcycling. So those are the challenges and these are the themes. So I just give as example how this stand. And these are like two individuals, just again to show the how the sometimes we can say it's the chemical engineering principles. And if you look at both Andy Grove and Jack Welch, and Jack Welch is the what we call the 20th century Professor Emeritus of Management from General Electric. He is a chemical engineer, PhD, and his forte basically was in transforming an industry to one of the number one in US at the time. And Andy, of course, should be well known, but again, he is the father of the microprocessor of Fine because it's Andy Grove, and then of course Michael Grove, who's you have you have this Andy is one who's transformed the semiconductor processing, and of course one of the founders of the Intel. So you can see, so it's interesting. If anybody is interested, you can dig into these names of these books and read the life story. And specifically, like Andy's one who is has been credited with the Silicon Valley transformation for the semiconductor area, right? Is very, very interesting to read, to understand how his knowledge of fluid mechanics has changed, enabled the semiconductor processing when it started at Intel, enabled this to happen. So it's very interesting. So we cut across all types of processes, and that is our forte. But if you learn well and you get these fundamentals. And to close my small presentation, just to introduction and hoping for interaction. Now, whom you are seeing on the screen is today's world's most patented engineer. And he's a chemical engineer, and Robert Langer. You can go into MIT in bioengineering, and you will find him as a chemical engineering professor there. And what is interesting is today in the COVID-19 vaccine platform, it is his startup Moderna that is on a new RNA. It's a therapeutics company, and based on this new technology, the first vaccine to come up onto the front runner in the race for COVID. So you can see that, right? And it is not just for the COVID, because that platform will be for many, many diseases, because it's works on RNA messenger systems. So it's interesting. I hope I just gave you a kind of like a glimpse, the potential, but I stress as undergraduates, we will be looking at fundamentals. And if you engage well, the sky is the limit, and with some happiness and passion, that's important. Today we have our students working both at Intel. We also have one of our past graduates in Bristol Myers Squibb working on the COVID-19 vaccine. So again, from our department, so these have been recent graduate. The Intel person has been some time, and we have them mostly outside Sri Lanka. That's one of our issues. We have majority of our students have gone outside simply on an issue of lack of industry, but COVID has changed, and we believe that in Sri Lanka now the industry has to happen. if we are to move forward. Now that's a very fresh opportunity for chemical engineering, and we have to give that leadership, and we are hoping to give that leadership. So of course in Sri Lanka we do have leaders in chemical engineering. That is, I just want to show you the example. If you've just been crossing our department in some way, we are now just getting to this 24/7 research lab, which was gifted by Mahesh Amalian, and Mahesh is the founder of MAS. So if you take, he is a chemical engineer, and I can relate to a few others. Sri Lanka's innovation ambassador is also you may have heard of Dr. Bandula Vijay, who has innovated on heart, the stent, and working from California. He's a chemical engineer, but he's a Sri Lankan ambassador, international ambassador for science, technology, and innovation. So interestingly, chemical engineering, but there's so much to give back, but we want enthusiastic, some passionate students coming into the field, and that's important. So I wish you all the best, hoping to interact next, but I'll stop my presentation here. Over to you.
Thank you, sir, for those very insightful words. It's an honor to have you here with us today to inspire these youngsters. I hope you saw how even the forerunners in the race for the COVID-19 vaccine are chemical engineers. And I hope that is also an interesting fact for you when you consider the current global context today with the field that we are currently talking about. So without any further ado, we will move on to the next speaker for today. And let me introduce him. Mr. Susiri Costa is a lecturer at the Department of Chemical and Process Engineering at the University of Moratuwa, who is currently studying for his MSc in Financial Economics at the University of Colombo, and has already completed his BSc Engineering degree at the University of Moratuwa. He has completed his chemistry degree at the Institute of Chemistry, Ceylon, and he is a past finalist of both CIMA and CFA exams. His interests lie not only in the fields of chemistry and chemical and process engineering, but also in areas like management, finance, analytics, and artificial intelligence. Second semester students of the DCPE will be meeting Mr. Costa as a lecturer of the Chemistry for Engineers module. He is a young and energetic lecturer with unconventional teaching methods who is always prepared to challenge his students to go beyond their boundaries. Sir, over to you.
Okay, thank you very much, Dinidu, for your introduction. As the official field familiarization coordinator of the department, I would like to thank the 18th batch for organizing this event. Actually, we only had very limited sessions this time. And now these guys have the opportunity, the 19th batch, to know the chemical and process field. So especially during my presentation today, as the time is very limited, I'm directly moving on to talk about what our department is offering specifically for the graduates, for the undergraduates in the department. So I will give a brief introduction. After that, I will directly move on to the context of the current undergraduate curriculum and how the things are happening at the department. So I'll directly move into my presentation. Okay, first of all, welcome to the Department of Chemical. I hope you guys can see the presentation. Dinidu, can the others see the presentation?
Yes, sir, we can see the presentation.
Okay, thank you. So welcome, first of all. First thing we need to ask from you guys is, are you a challenge seeker? Are you looking for a challenge? Or are you going to be a very traditional engineer who's going to end up in a very traditional domain? So the choice is yours. If you are ready for a challenge, I hope you guys are ready for I hope you guys are ready for the challenge during the A-level times. And even now, I hope you guys are looking for a challenge as an engineer at University of Moratuwa. So if you want to solve the biggest issues on earth, not in Sri Lanka, not on a very limited scope, if you are going to solve the biggest issues on earth, the chemical engineering is the best choice. So if you look at our domains, we have the water, food, energy, and health, all the critical domains that are required for the survival of the human beings are covered up under the chemical and process engineering. So our alumni who have passed out from our department already worked in different domains, including water, food, energy, and health. So if you look at the current context, as Professor Ajith mentioned, currently 2 of our alumni are working in the vaccine development projects, as well as if you look at the other aspect, even on the impact of the economy from the COVID is analyzed and got appreciated in Australia from our graduate. Actually, a batchmate of my batch is currently doing his PhD in Australia regarding the COVID-related economic impacts, which is one of the most highlighted economic research in this context. So you can see the chemical engineering scope is not limited just to chemical engineering. We are moving from, as Professor Ajith mentioned, from the nuclear engineering to bioengineering. So it's a vast amount of a range. Another highlighted point in the current context of the world is the climate crisis, where you guys can understand the carbon footprint identification, the green concepts, the clean energy, the zero emission concepts, the everything that comes in combined with the chemical and process engineering. So these are very friendly moves in the world where you guys can apply your knowledge, but you learn as a chemical and process engineers in the department. So I would say, if you are ready to challenge the challenge, be a chemical engineer. Don't be a chemical engineer just to be a boring guy. If you are ready to challenge the norms of the world, this is the place for you guys. So I think Professor Ajith also showed what is chemical engineering. Therefore, I'll move into the next slide. So what we are going to do as a department. So during the 3.5 years that you guys stay within the department, you will get the time to grow from an undergraduate, actually as a fresher who is just coming from the A levels, who do not have much idea on the engineering, to be a proficient engineer who's very capable of the techniques and the skills required for engineering. So it's the duty of the department that we produce a very high profile engineers to the environment. So if you look at your pathway at the department, from the semester 2 to semester 5, there will be the regular lectures as you guys have on the semester 1, where you will attend the lectures, you will have exams, you will have assignments and other minor projects. And in the semester 6, you guys will go for your industrial training, where the department will provide the placements. So majority of our guys, currently a batch is going for the industrial training, and the places would be very high profile industries. So after the semester 6, you guys will return back to the university, where you will have a semester called the 6B, and the final year semester 7 and semester 8. During that time, you will undertake your design projects and the final year research projects. So if you look at our curriculum, there are many subjects. So just to highlight few subjects, I have taken few of the main subjects in our curriculum. That includes thermodynamics, fluid dynamics, chemical kinetics, unit operations, reactive engineering. So there are different subjects which cover up different various fields, which I can tell, as Professor Ajith also mentioned, chemistry, physics, mathematics, and biology. So you will get exposed to all those 4 fields during these subjects. So in the final year, you will get exposed to the final design, where in the semester 7, you will do a group design for an entire chemical plant. And in the semester 8, you will do an individual design for an individual processing equipment. So that will be the climax of the engineering. That is the final output or the top end of engineering at the undergraduate level. Simultaneously, during the semester 7 and 8, you will do a research. So this is the speciality of our department, where you will get the chance to do a design as well as a research. And most of the departments, you get the only chance either for a design or a research. Here, you get the chance for both the design and the research. So if you come to the final year at our department, you can see we have 4 specialization. First is the petroleum, then we have energy and environment, then food and biochemical, then we have the polymer. So all these specializations give you the minor where you can directly go into that industries. If not, you can get a general chemical and process engineering degree where you can select subjects from petroleum, food and biochemical, whatever the baskets you like. If not, you can stick to one basket and be a petroleum engineer, energy engineer, but whatever the thing you select, still you will be a chemical and process engineer capable of doing anything related to chemical and process engineering. So after the degree, what are we offering? We are offering the widest range of jobs for the engineers. The engineering, when considering the other engineering scopes, this is the field that provides the widest range of jobs. Our engineers work at multiple avenues, considering their talent skills they have developed during their undergraduate degree. So at the end, you can decide whether you are going to follow an industrial career or an academic career. So that's up to you to choose whatever the field you like. So last year, we had 50% employment rate just before the final exams of our undergraduates. That means before even they go out, 50% of the undergraduates had already secured jobs at the industry. So these are very few companies where our graduates work. So you can see those are very big names in the current industry. Manchi, IFS, Unilever, Palvatta, Ansel, Fonterra, Food City, Cargill's, MAS, Loves, Haley's. Those are very, very big size companies in the Sri Lankan market. Even as a multinational companies, these are very big companies. So now you can see the scope of chemical and process engineering in Sri Lanka even. So in the context of the department, there are a few new initiatives taken at the department. One is a research club. There is a research club where you guys can work together to do new research as a team. So you can join the research club and do the research as you like. Then there is a 361 program where we train you guys to be better undergraduates with the enhanced soft skills to get into the industry. Then we have a program called Alpha, where we are going to try to help our students to improve their English speaking abilities and their writing abilities. Then we have a program called Katabaha, where undergraduates get the opportunity to get exposed to the industrially experienced guys and even the academia from abroad even. So very recently, I think we had many Katabaha sessions where in the past year, we had people from Norway, Australia, and different countries to speak about their experiences with chemical and process engineering. So if you ask why you should be a chemical engineer, I would give you 4 reasons. First is, under the global context, you would have a very high salary, not under the local context. Second is, we are solving the biggest issues on earth. Third is, we provide the widest range of jobs. Fourth is, no one on earth survives without us. So if you think from the morning to the night, without chemical and process engineers, you won't survive. From your toothbrush to the bedsheet that you are using, everything is produced by the chemical and process engineering. For everything, there is a process. Therefore, chemical and process engineering is vitally essential for you guys to survive. So if you think you are ready to take the challenge, so if you are ready to be a proficient engineer, I think chemical engineering is one of the best fields. So the choice is up to you. If you like to be an electronic engineer, be an electronic engineer. If you like to take a challenge and be a chemical engineer, there is opportunity for you to achieve that too. So I guess that ends my presentation. So over to you, Dinidu.
Thank you very much, sir, for those very insightful words. And before we move on to the next speaker, I want to kind of remind you, if you have any questions, you can please post them on the chat. So I'm sure you all have questions, so don't be scared to ask them. The speakers here today are very approachable, very friendly. So please get your doubts clarified. Please get the maximum use out of the session. So interact as much as you can. So please, for now, just if you have any questions, if you want the moderator to direct any questions to the lecture panel during the panel discussion, please post your questions on the chat. Okay, so now we shall move on to introduce the third speaker for today, Mr. Anushan Ranendra. Mr. Anushan Ranendra was a past lecturer at the Department of Chemical and Process Engineering at the University of Moratuwa. He completed his MSc in Innovations Entrepreneurship and Management at the Imperial College Business School, UK, and his BSc Engineering degree at the University of Moratuwa. Since graduation, he has obtained work experience in several leading companies in the industry and participated in many corporate projects involving areas like environmental sustainability and resource and energy optimization. Mr. Anushan currently works as a senior business analyst at MAS Holdings. He is an out-of-the-box thinker who is extremely friendly, eloquent, and organized. It's safe to say that we have much learned from him with regard to the industry and how to build your career as a chemical and process engineer. Sir, over to you.
Hi everyone. Hope you guys can hear me and hopefully see me. Can you guys hear me?
Yes, sir.
Yes, sir, we can hear.
Okay, so before I start, I need to say a few things about my introduction. I don't know whether I'm well organized as you said, but I would take that. So first of all, before I start, I need to say my kind apologies for quite a few things. First is I tried to log in from my computer, but didn't work, unfortunately. So I had a presentation prepared. I don't think I'll be able to share it with you guys. So apologies for that. And also, this was a bit last minute for me. So might not be as eloquent as the introduction mentioned. Anyways, so basically, my talk will be in twofold. Firstly, I'm going to talk about my story, how what I did, how I came through my ranks and where I am right now. And secondly, an industry perspective in terms of what kind of job opportunities you guys would have as chemical engineers and what is expected from the industry from you as fresh graduates when you graduate in hopefully another 3.5 to 4 years time. So first of all, I'd like to just give you a brief overview of who I am, what I do, and where I come from. So I studied at Nalanda College. I did my primary and secondary education there. I completed there, and then I got into University of Moratuwa, where in 2010, where I did chemical and process engineering. Actually, it was my choice to do chemical and process engineering because I felt that it was something very tangible, something that you could see, feel, touch, and feel. So that was the reason why I decided to do chemical engineering. And during my tenure as a student in the Department of Chemical and Process Engineering, I had some, I would say, exceptional memories, things that I would never forget. And in terms of my academic scope, I think there are quite a few things that I cherished and I am really proud of. First is the research project that I did. This was an industry collaboration which we did with A&E, which is a palm oil manufacturer, one of the largest in Sri Lanka. So the project was to basically remove pigment or the color in the palm oil wastewater, which was an absolute success. We were able to remove 60% of the waste, the pigment, the color in the wastewater of the palm oil, rather the wastewater that is generated from the industry. That is something that I'm really proud of as a student. And also we did some very interesting projects. To start with, my final year project was to design a plant to convert waste lubricant oil that is used in vehicles into fuel. So this was something very exciting, which we did during our final year, and something that I'm really proud of. I even speak about it at, even at interviews when I go to, that this is something I did. And also we did other projects like storing methane to be used as vehicular fuel. These were all very exciting projects that I did during my undergrad. And after I graduated from the University of Moratuwa in 2015, I was here and there, I would say. I did quite a few jobs, and I gained a lot of experience in different sectors when it comes to my experience. And then I actually did my master's in innovations, entrepreneurship, and management at Imperial College London, like Dinesh said. This was in 2017. Uh, if I have to talk about my work experience, well, I first of all started working at 3M Lanka Private Limited in 2015 as a technical sales engineer. During my tenure as a technical sales engineer this was for about 8 months, I would say. I actually worked in the industrial tapes and adhesive division. I actually led the team in terms of technical support. And we did a lot of research and collaborations with people from Singapore, US, China, India. And we launched several new products in Sri Lanka. Also, during my tenure as a technical sales engineer, I actually pioneered the successful introduction of several new products in the Sri Lankan market. So these were all very technical stuff. After that, what I did was I joined MAs as a sustainability and operations executive. Uh, this was a very exciting period in my life because I believe that this was where I was able to kind of personify and embody what I learned during my undergraduate studies as a chemical and process engineer. Uh, at MA's Active Shadow Line, where I worked as a sustainability and operations executive, I was in charge of a card of 30 people, which was basically the engineering department there. I was in charge of managing the sustainability arm, the general and utility maintenance, which was a plant of 1,300 employees and roughly a plant which consumed over 1 million megajoules per month. I also was a part, basically pioneered, I would say, the ISO 14001, ISO 14064, ISO 18001 for the year 2016 and 2017 at Shadowlight. I also was a part of the projects team where I implemented and initiated a multitude of different projects, which I'm very proud of, to be honest. Out of those, I would say my highlights were implementing and designing and implementing a rainwater harvesting unit of 15,000 liters there. I was also a part of the team that installed a chiller system, a 450-ton chiller system, which is basically a centralized air conditioning system for the entire plant. Also, during that time, I was a part of the team where we implemented and installed a new steam distribution system through which we were able to reduce the energy consumption roughly of about 20%, an year-on-year reduction. Also during this time, I was a part of the central team, which was formed to remove the rhodamine dye, which is a very common dye that is used in the apparel sector, in the apparel industry, and which is quite harmful to the environment. And I was also a part of the team which led and pioneered this project as well. Also, I would say another highlight of my tenure would be basically implementing a wastewater treatment unit within the facility that I worked in. And these were, well, first of all, I must say, I might be all over the place. Apologies for that. But the reason why I'm telling you all of this is because what made all of this possible was what I learned and what was instilled in me as a chemical and process engineering graduate from the University of Moratuwa. After that, this is when I actually went to do my master's in the UK. During my master's, I was also a part of several projects, which were quite interesting. I was a part of a consulting team for one of the largest consulting or groups in the Europe, which is known as Bearing Point. We did a project to basically create a vision, a macro and micro level vision for customer service centers for retail banks in the UK for the year 2025. So this was more of a visionary project and something that I really cherished. Also, even though I was studying innovations, entrepreneurship, and management, I must say, due to my background of chemical and process engineering, I got the opportunity to work with world-renowned organizations like Shell and British Petroleum, where I was a part of a team where we designed storage units and basically a control system to reduce corrosion in those storage units. And I must say, these opportunities were dawned on me or came across my way solely because I was a chemical and process engineering graduate. And I must say, people all over the world really do appreciate graduates from the University of Moratuwa and especially from the Department of Chemical and Process Engineering. Hence the reason why I got this in the first place. After that, I again came back to Sri Lanka in 2018, the latter part of 2018. Then I joined the University of Moratuwa as a lecturer on contract. That is where I became very good friends with Costa, who actually made a wonderful, a fabulous presentation before me. During my tenure here as a lecturer at the University of Moratuwa, I got the opportunity to teach several core modules, which included environmental science and technology, unit operations, process design and integration, and so on. I also got the opportunity to work with the industry during that 1 year, where we did several projects in terms of wastewater treatment. So we designed a wastewater treatment plant for Lanka hospitals. And also I was a part of a team that basically designed, or rather pioneered the replacement of the existing wastewater treatment unit at Haley's Fabric PLC in Horana. And also I was a co-pioneer, I would say, in the two programs that Costa mentioned before, the Alpha program and the 360 program. So that is something again that I'm very proud of. After that, I decided to take a break from academics and to move to the industry again, because I believe that that is where my passion truly lies. So after that, what I did was I joined MAS again as a senior business analyst, and I must say, I'm actually having a wonderful time. And I have been entrusted with a lot of responsibilities as a business analyst. And I will just brief you, give you a basic overview of what I do right now as a graduate of the Department of Chemical and Process Engineering. Well, I basically lead the team of a project known as Turnaround. This project is basically driven across the entire MAS. So I basically drive this initiative where we are supposed to save $50 million in 2 years. So we have been we have implemented and initiated a multitude of different initiatives, which include energy projects, raw material consumption, manufacturing, capacity optimization, delivery optimization, and whatnot. So what I believe is what gave me the ability to perform what I do, the confidence that I have to perform my job, was entirely and solely could be attributed to the education, the knowledge that I gained as a chemical and process engineer. Well, that's about my story. And then I would like to move on to the second phase of my talk, which is the industry perspective. I wouldn't want to, basically spend too much time on this. I think that you guys would have a lot of questions to ask from me, and I believe that it is a very effective way to connect and to understand and to learn what you need. Well, basically, what I want to say is that as chemical engineers, there are a lot of job opportunities in a lot of huge multinationals and also local companies. So a few of the organizations where my friends, my batchmates work, are MAS, Avery Dennison, Brandix, Hydramani, UNICEF, 3M, Nestle, Ansel, Fonterra. These are all world-renowned, world-recognized brands and organizations, and these are some of the places that our friends, my friends personally, are working, and they're very proud of what they do. And what made all of this possible for all of them was the education that we gained during university. Apart from that, honestly, like I said, I'm not very well prepared for this. But anyway, that's about my story. I think you guys would be able to pick my brain and get more insight in terms of what the industry expects from you and what is the industry like for a chemical and process engineer in the Q&A session. So Dinidu, over to you. I would love to answer any questions you guys have.
Right. Thank you very much, sir. And we are actually really sad that Anushan sir is no longer with us in the department, but we truly believe that he is a great asset to the industry, as I'm sure you would have understood from what you heard. And I remember it was a funny story that I remember last year we had a field visit batch, and this is to prove how eloquent he was, how interesting of a lecturer he was. We went on a field visit to KIST, I think, and towards the end of the visit, I remember most of us had left the guide and we were listening to Anushan sir's stories about the industry because he was telling stories about his own personal experiences. And so that was how eloquent he was. That was how interesting his stories were to listen to. And so that's just an interesting story that I remembered from when he was speaking. And I think now the audience would have all got familiarized with our speakers today. And I'm sure you would have posted some questions on the chat as well. So I think the time is right to move on to our panel discussion. And to start the panel discussion, I want to invite all three speakers to please switch on their videos if possible, Ajith sir, Costa sir, and Anushan sir, so that we could have a easy, fruitful discussion. And I want to make a kind request to everyone else. Please keep your microphones muted. This is a kind request. Please do not disturb this session because there are a lot of people who are willing to gain something out of it. So please make sure that your microphones are muted unless you want to ask a question or provide something useful or insightful to the discussion. Then otherwise, please keep your microphones muted so as not to disturb what is being discussed. So I hope the three speakers can switch on their videos. And yes, thank you, everyone. And I know it's kind of difficult to have a panel discussion under these circumstances, and it's very hard to address the questions direct to one person. So I have a few general questions with me, which we will address first, and then we will move on to the questions that were posted by the audience. And these questions are general questions, so I'm sure all three of the speakers can provide some insight, or the most suitable speaker can provide some insight. And some of these questions would have all been addressed already by our speakers as they spoke. So I think one of the main concerns our audience had been having was the specialization opportunities that our department offers, and what the specialization departments are. Could someone please elaborate on what the specialization streams are and what comes under each of those streams? I think that would be useful for considering the questions we've seen.
Susiri can do that. Susiri.
Okay, sir. So basically, we have 4 specializations. First is the energy and the environment, where you will learn about the renewable energy, the clean energy concepts, which are one of the currently trends in the world. So you can get a specialization under the energy and the environment from our department. Then we have the specialization under the petroleum. So the upstream, the downstream processing, and you can get majority idea about the laws and the economics related to the petroleum industry from the petroleum miner. Then we have the polymer miner, where you can learn the polymer processing techniques, how the polymers, plastics, polyethylene things are produced and manufactured, and how the nutrients move on. Especially you can do the designing, mold designing, and the processing, both the parts, the product designing and the processing parts under the polymer. And the 4th one is the food and biochemical. So under that, I think Ajith is an expert in that field. So you can learn much about how these food-related chemical engineering, not just how the bakery level things, but the higher level, the advanced level of the food processing techniques happen in the industry. So those are the major 4 specializations that you guys can get. But that doesn't mean it's a mandatory requirement to get a specialization. That means if you like to do a subject from food and from polymer, you can be a general chemical and process engineer. So if you like to specialize in one field, you can be a specialist engineer in one field. If not, you can do multiple subjects selecting from different minors and be a general chemical and process engineer?
Yeah, I would like to weigh in here. I actually minored in energy and environment, and I must say that the course provided quite a comprehensive, syllabus and content, which actually enabled me to do a lot of what I have done. So hats off to that. Yeah.
So one student has also specifically asked in the chat, where would, if he wanted to study pharmaceuticals, which stream would he have to specialize in? So that was one question I noticed. If he was going into the pharmaceutical side, what specialization would he want, should he go to?
To do the pharmaceutical, it has to be the biochemical, the food and biochemical, so it's chemical engineering.
Just to add to that, I think this time the design supervised by Professor Ajith and myself was a pharmaceutical plant, this design given. At the same time, my internship, I did at a pharmaceutical manufacturing plant, which was expected to be the largest pharmaceutical plant in Sri Lanka. So if you do the chemical and process engineering, directly you can go into the pharmaceutical industry in Sri Lanka.
Right,
Adding that, now there's a big interest in pharma, so we are hoping to have about 25 more pharma companies coming in with manufacturing plants. And also there's an additional biosimilars and drugs of that nature coming up, because again, a biotechnology innovation park is to come. So there are a lot of opportunities opening up in this particular segment.
Right, thank you, sir. And I think we also had questions. I think Ajit had answered some, but I think everyone would prefer it if you shared it with everyone now. How would, if we consider the area of nanotechnology and the area of nuclear engineering, we think it comes under, because we are slightly confused. I think everyone was slightly confused as to whether chemical engineering would relate to nanotechnology or nuclear engineering, or if it actually does relate, what kind of pathway would a person have to go through once they complete their degree in chemical engineering? If their real interest was either nanotechnology or whether it was nuclear engineering, how they would approach that pathway after having completed their degree, or how they should choose their specialization in order to go on such a career path.
If I to add to that, it's interesting because when I started chemical engineering, actually I decided to do chemical engineering because of the interest in chemistry some time back. And I still remember a book that I read in British Council on chemical engineering around grade 7, grade 8. And that prompted me to actually at the time stop even chemical engineering, and I opted in to do applied science because Moratuwa at that time was applied science. Chemical engineering was in. The most interesting subject in the department at the time to me was the nuclear engineering, nuclear one, which was part of the fuel science program. Because we had a lecturer who has done our former head has done on thorium processing. When we have thorium in our sands, we have it off Kalutara. We are not yet processing, but now Nanotechnology Institute has worked out a thorium process. Of course, we need to investment and to develop into the next stage. But of course, our neighbor India really did that whole process in India by themselves, right? Something that we can also try to attempt. So the way is, you will be doing process engineering. So we understand, as I said, this how to manage, develop, design, and the equipments for a processing. So whether it's a nuclear process or a bio process, we need to then understand the specifics of the bio or the nuclear and then move on with it. So the fundamentals stays the same. That is what is important about the process engineering. We work with the fundamentals of the thermodynamics on the first law and the second law and so on. And so we look at the energy and we look at the material, and whether the material is nuclear material or a biomaterial, then we adjust and work with that mindset. But our knowledge base is what is important. That will enable you to shift gears into this direction. Now, again, coming back to myself, when I was first getting the postgraduate opportunities, I got at Imperial on the nuclear. But then I went ahead and did my postdoc PhD in food engineering. So I shifted from nuclear to food, though I like nuclear, but I went into the food opportunity. So it's just chemical engineering. Chemical engineering can shift courses very easily because if the fundamentals are, I mean, the way you receive your fundamentals, and if you have adhered to that, you can achieve great things.
Thank you, sir. Would anyone else like to add to that? Would any of the other speakers like to add?
I think we can move on to the next question.
Right. Okay. So I think I would bring up the elephant in the room. There is a very obvious question, I think, that is offered to always to our department, in which case of the job opportunities in Sri Lanka. So there is always a rumor that there are very few job opportunities in Sri Lanka for chemical engineers, not because of anything else, but because of the lack of chemical industries and the lack of chemical industry initiatives taking place in Sri Lanka. So is this true, sir? What do you think is the future of chemical engineering in Sri Lanka? What do you think, what kind of opportunities do you think would be available for these students if they graduate and decide to stay here and work here in Sri Lanka?
So if you look at the context, I think I personally have applied to many jobs and landed in every job that I applied. For people, I think if you are competent enough and if you have developed your skills, landing on the jobs in Sri Lanka is not that hard. It might be not be 100% chemical engineering, but still something related to chemical engineering, maybe combined with the economics or management. So there are job opportunities. I think even Anushan have got a good job offer initially. Even my initial job offer was 120,000. So at the same time, I got the job offer from Heineken. Even the final interviews were held at Singapore. But as I joined the university, I had not to take that opportunity. But I think there are opportunities, but people need to be competent enough to get into the positions. But on that note, the jobs might not be 100% fully technical chemical engineering. Some might be full 100% technical chemical engineering. Some might be a combination of management and chemical engineering. So there are a variety of jobs offered in Sri Lanka. So I think there are enough job opportunities. And even in the last batch, we saw the students landing in good jobs even before their graduation, even before their final examinations. So I think that's my insight. So the lecturers also can explain their things.
I would like to add to that
Yes,
since
sir.
I'm the industry person. Anyways, yeah. So, like Susiri said, there are, I mean, the opportunity to pursue a career in hardcore engineering is not necessarily, I wouldn't say it's not, it's non-existent. It is for sure. But given the context in Sri Lanka, the industry and how it has panned out, I would say hardcore engineering jobs, chemical engineering jobs, would be not difficult, but you would have to find. You would have to, be on the lookout for them. But that being said, I have a lot of friends, I have a lot of colleagues who have done exceptionally well, pursuing careers that do not go hand in hand necessarily, but that are related to chemical engineering. For example, myself, what I'm doing right now is, I wouldn't say exactly related to chemical engineering, but I believe that the chemical engineering course essentially grooms a person to obtain all the core values, the core competencies that are required to perform a job. Because I know you guys just just finished your first semester and you have aspirations to be great engineers and change the world and whatnot. But when you come to the real world, doing a job is very much tough. It's not about the technical know-how. It's not about the technical competence. It's actually about the soft skills that you have. Things like meeting deadlines. For example, how many of you submit your reports on time? Something that is very hard to come by students like that. But those go a long way when it comes to doing a job. And I believe that university properly grooms a student to obtain and acquire all those soft skills, perseverance, dedication, being committed to a cause. These are some of the things that you need to inculcate during your tenure as students. But when it comes to job opportunities, there is ample opportunities for students who graduate from the department. But again, having said that, would not necessarily be 100% related to chemical engineering. but there are so many opportunities available.
Thank you very much, sir. And now I want to move on to another area that the chat has been addressing. This is another question from our audience. So I think there are a lot of students who have been computer science enthusiasts and have not gotten a high enough rank to apply for computer science and engineering. And they are very curious or interested in learning whether a computer science enthusiast who also becomes a chemical engineer, what kind of places or what kind of opportunities does he have in either in research or in industry to apply his digital knowledge in a chemical engineering context. I would also like to mention, because I remember there was this rumor that saying that chemical engineering is kind of outdated, and in an increasingly digitalized working environment, digitalized a world, a future that we're looking at, it might sound like an outdated industry or an industry where you cannot apply your digital skills. So to clear out that doubt, I want to invite you to clear that doubt for our audience, because there's been a lot of questions.
May I start?
Yes, sure. Go ahead.
Chemical engineering will not get outdated. It's about, we have to have the periodic table, what's in there, and being transformed into all sorts of things. So the transformation is part and parcel. What we may have, what is we're having, I mean, if you take the industry 4, it's cyber physical systems. So we have a physical system and we are coupling the cyber system. So cyber physical coupling will happen, and that is part. And this day and age, we tell that even youngsters, you need to start with coding. And it's a fantastic asset if you come with the coding knowledge, right? Because it's just not only in silico we are talking about genetic coding now, right? So it's biotechnology. We are actually taking stuff out. We use the bioinformatics. We actually reorder the gene. So it's not just silicon stuff now. It's really changed, like the CRISPR technologies. So coding is important, and if you are an enthusiast in that, by all means, it's important for you, and you can do lots more rather than just being a computer scientist, and it probably will be more exciting. For instance, if you look at in the industry, we talked about this cybersecurity, and we have had, we talk less, but we have had situations where viruses been done to control industrial processes, and centrifuges being run at high speed from a different country and destroying the process, right? So process control systems are part and parcel of any process. And I said the beginning also, we are not talking about manual labor. We shy away from that from the very beginning. I mean, we never use manual labor in that way. So it's all about mechanized, automated systems. And the more and more the digitalization is creeping in. So absolutely no issue with chemical engineering. And the more you have that enthusiasm, you can bring that energy in, knowledge into this, and you can have a much better prospects through that.
I think Susiri can actually weigh in because he's doing quite a few interesting projects, if I'm not mistaken. Susiri, would you like to please enlighten?
Yeah, just speaking about the new concepts like machine learning and deep learning. Recently, I think in the last conference I spoke, I published my paper on the deep learning model to categorize the active and inactive drug compounds in the pharmaceutical industry. So if you think at the end, the process optimizations, everything that you learn in the final years, the technology is moving on. Now the things are moving on to the machine learning, and not only to even to the machine learning. So if you have a machinery, then you can use the IoT technology, then connect to the cyberspace, then control through the machine learning and deep learning models. So the robotics, the computer science concepts, the machine learning, deep learning, even the reinforcement learning, everything is coming together. So actually those things are not necessarily now the computer science tools. Those are tools that can be applied to any engineering discipline. So the chemical and process engineering, even all around the world, moving towards these concepts. So the optimization, the plants, the smart factories moving on. So there is ample opportunities to do research and to develop new knowledge in this field. So I think even in the last batch, we had a student who was very interested on the electronics, and even he did projects for the electronics department. So that is what your interest drives you in. So if you have that interest, there is always opportunity in this department to apply your knowledge, to apply your skills, especially if you have the coding skills in the Python and the data science skills. Yeah, there is opportunities. So it is not that chemical engineering is outdated. Chemical engineering is moving hand in hand with the new computer science and the electronic concepts right now.
Yeah, if I may add just a small thing to that, like Susiri just mentioned, there are so many opportunities that have, or other areas that we have not ventured into, especially when it comes to machine learning and artificial intelligence, because what we learn as chemical engineering are the fundamentals, and there is so much scope to incorporate those fundamentals into the digital spectrum, like what Susiri has attempted. So. Since this field is not properly established, I believe that there is so much opportunity for you guys if you're actually interested in computer science.
Thank you very much, sir, for those insights. And I think moving on to another area that the audience seems to have been interested in, they seem to be asking whether management, I think management is very close related to chemical engineering, because chemical engineering itself is so familiarized with the industry. It has very close ties with the industry itself. And so everyone is curious as to whether another management qualification such as SEMA, or whether knowledge in economics or finance would complement this degree, or how would a student who eventually wants to end up in a management position, whether this would be the correct choice for them, and if so, why?
So, you want to take this? You are the master.
So looking at the context, I did SEMA and CFA, of course, to get the insights regarding management, because I was interested in management. But if you still want to get the concepts and the ideas of management and economics, the degree provides the modules. The degree has business accounting, the degree has entrepreneurship minor, then the degree offers business economics, then the degree has subjects related to every engineering related management concepts. So it doesn't mean you should have a qualification like SEMA or any other finance qualifications to move on to a management job even with this degree. With the chemical and process engineering degree, you get a ample knowledge regarding the management and the business concepts and the engineering context. But if you still like to do something like SEMA or something like related to management and finance, yes, of course it would complement. But that doesn't mean it is essentially required for this degree. But if you like to do it, if you have that commitment to learn more things and get exposed to new things, yeah, of course you are welcome to do it.
Thank you, sir. Moving on to a new area that there seem to be a lot of questions about. It's about the research at university. And there seem to be questions asking what kind of research opportunities there are, and what kind of interesting researches are going on right now or have happened as of late, and whether the students could even start a research of their own, and whether they could select a desired topic. How would the process of research at the labs in our department, how would they work? A small, brief summary of how researchers function in university. I think that would really help the students.
I will start, then you can add. The research is fundamental to a university. Whatever the field that we are doing, universities shine when research shines, right? So it's research output that is very, very important. So we also understand that fact. And research is happening, and we do have some very interesting research going on, from polymer to the bio side and in the food. Specifically in bio, I can identify with respect to like the nutraceuticals, from like nutraceuticals like astaxanthin extraction from seaweeds, a very, very high value product, a very hot topic. And when you do that, there is lots of neural nets modeling and used, because you have to model the environment. So you can see that it's practical work plus mathematical modeling and simulations are coupled into that. Then we do have two, our department has one of the industry labs like the DSI incubator, and DSI incubator is not like the basic research, it's applied research. You take on industry projects specifically for the DSI group in the polymer and the rubber sector. And they have had some very good successes in, because that's one of the oldest labs in the university as an industry lab, like the electronics, the dialogue lab at the electronics. So we also have the food lab with Cargill's. It's stopped now, but it's interesting. Yesterday, I received a call from Cargill's. They want to initiate the lab again. That's a sign of times, because this day the agri-industry and manufacturing after COVID, there are so much of interest in manufacturing in the country. So we see quite interest in setting up industries, and almost all of these industries are process industries, right? And even to have e-commerce, you have to have products. So it's very interesting, the interest timing. So we may actually reopen the Cargill's food process development incubator again. And we are hoping to have some more labs like Harsha Subhasinga's Vega. Again, a very serious interest. He has a very serious interest in chemical engineering area. And there will be an opening of a lab in our department. So there are lots of interest in research, and like the 24/7 lab, but Mahesh supported, is purely for students to work on 24/7, 24 hours, 7 days of the week. Students will have access. You just have to have your project area, maybe even an area of your interest, and the department will be supporting that. So, that's just a few examples. Susiri.
Just if I speak about the research, how the research happened at the undergraduate level. So it's a group research generally what students get, and you can contact the supervisor. The supervisors would have their topics. At the same time, if you need to suggest a topic, an interesting topic that you feel that is very trendy one, so you can suggest to the supervisor. Though when the supervisor agrees to supervise the team, so you can move on with the research project. So generally, it will take around 2 semesters to complete the research. So at the end of the final year, you will have a good research outcome from your project. So that is how things happen in the undergraduate level at the department, how they select the supervisors. And so you have the opportunity to select the supervisor according to your will.
Thank you, sir.
Dinedu, before we
Yes.
move on, is it okay if I excuse myself because I have a meeting in a bit? I'm extremely sorry.
Yes, sure, sir. We thank you very much for joining with us, and even though with your busy schedule you joined, so thank you very much.
It's a pleasure. It's a pleasure, and I apologize if I did not live up to your expectations. And
no, you surpassed our expectations.
I actually would like to thank you all for giving me this opportunity. Thank you, guys. Thanks a lot.
Thank you, sir, for joining.
All the best and good luck.
Thank you, sir. So afterwards, we still have a few more questions coming in from our participants, so we have to address those. I think there was another lot of questions regarding higher studies opportunities, especially foreign higher study opportunities, and what kind of opportunities there are for the students once they've completed this basic degree to go abroad and study further, and what kind of areas they would be able to go into, and how they should approach if they have ambition of doing further higher studies in a foreign country. Could someone please elaborate for that? I'm sure they would find it very useful.
I will start, Dinedu.
Yes, sure.
Hope you remember that I mentioned that most of our graduates are abroad. That's to start with the very first batch coming from 1972 onwards. We find very, very significant percentages outside. And that couples with the fact that what Susiri mentioned, if you look at, don't take our words for it, but just Google on salary surveys of by the Australian chemical engineering or to the Australian engineers or to the US, you will find chemical engineers, whether you're on the southern side part of the globe or on the other side, chemical engineers top the salaries in those countries, in developed economies. Unfortunately, that's not the same. Not the same in Sri Lanka. The reason is obvious, because we don't have those industries, and our economy is not developed so to give that much to such fields. Yet things hopefully would change. So the enormous opportunities outside. Now, if you take from, we had probably a very big cluster in Norway and Sweden, in the Nordic countries, who are really into safety, right? Because we went to the petroleum and the gas industries there, and there's a significant number in that. It's on safety, and I remember from Telemark, Professor Susiri was the person who started as the first graduate from there. And they kind of consider Sri Lanka as the place of choice for their students when you take postgraduate students. So we have maybe more than 20, 30, I think even more now, right? It's a huge number going there. So we have all over the place in the areas that Susiri mentioned. So if you take the food, environment, energy, the chemicals, the polymer, all those sectors are open. And as we have an undergraduate field that, our undergraduate curricula covers all those 4 segments, and with a co-curricula, we believe that those who do well with enthusiasm really has the grounding to secure a placement elsewhere. That's not a problem at all. But you need to pay attention. You need to be responsible for the challenges offered, and it just not graduate. The degree will not just be given to you. Now the placement will come to you. So you have to show your abilities as well.
Thank you very much.
May I ask a question from you?
Yes, sure. Lakshan, go ahead.
So one thing I've heard is the CS students can go for startups like very easily. Could a chemical engineering undergraduate start something of his own and become an entrepreneur?
I think we have examples of that, but you see the point with the computer science, sometimes I think Susiri may correct me. He has really a feel for this, and he's going to start enterprise. So our startup engine in the department. You see, when you're doing coding and when you're in that space, it's a kind of a different, to have the startup in a particular area with your knowledge is perhaps somewhat easier. Now, I'm not putting that as an excuse, because in a processing side, we have some additional inputs to come in to have the startup. But definitely in processing, we have had people who are looking at in the food industry. I think there was a recent example in chemicals. There are quite a few startups, but so the situation is, the environment is different. So for CS, there's a little bit of an easy pathway, because that's the way they normally probably start, with the coding only. Susiri can add to that, because department is starting the enterprise and he's leading that.
So just to add to Ajith's comments, the main difference is for IT or the computer science, the infrastructure requirement is very minimum. If you have a computer, 1 person, 2 people. So if you have a room, yeah, you can start a company. But for chemical engineering, that's a little different. But still, you can try it out, because there are people who have become entrepreneurs from our department who have had set the examples out there. At the same time, as a department, we are trying to set up a platform for our students to put up their ideas, new innovative ideas, to set up the new enterprises, so that they can go into the next level where they can secure funding from outside funders, and then either venture capitalist or anyone, or then go into the next level. So as a department, we are putting the effort to set up that platform. At the same time, if you have that real interest, I think there is opportunity for chemical engineers right now.
Okay, thank you, sir.
Thank you very much, sir. And again, if anyone has any questions, you are free to unmute your mics and ask them yourselves. If you can't post in the chat, please unmute your mics and ask them directly. That would also be completely fine. Are there any questions from the audience? Otherwise, we'll move on for now. So another question that we have to deal with is foreign employment. So a lot of questions have been asked whether you need to study, whether this degree is enough, or whether you have to specialize further and go for higher studies in order to apply for a job abroad, or whether simply you could just complete this degree alone and then start a successful career as a chemical engineer in a foreign country without further studies? Is it possible?
Susiri?
Okay, so there are people who have gone directly from this degree for the foreign employment, but the numbers are less because the easiest route to enter to a foreign country for the Sri Lankan is to go for higher studies and then shift to the employment. So that is the easiest route, but that doesn't mean that is limited, because if you look at how the foreign PR is given at Australia, it means you need to secure that number of points. So if you have that number of points, even with your basic degree, you can get the PR in Australia. But that would be much easier if you do some higher studies there. So you get some time to be there, and with the time you get there, around 2 to 3 years, you have the opportunity to apply for the PR. So that is the path majority of the students have followed. But still, there are few students who are working at the petroleum in Abu Dhabi and even in Australia who have taken the opportunity directly from the undergraduate degree.
Right. Okay, I'm sure that answer was very helpful to participants here today. I have a special question of my own. Otherwise, okay, there's another question from the audience regarding the Washington Accords. So the Washington Accords are also a very phrase that is used a lot, and I'm sure the participants also might not have a proper idea of what it means. So I'm sure the speakers could elaborate more on what it is and what kind of benefits it brings.
I will start answering, but you see, Washington Accord is about engineers' mobility. So Washington Accord kind of accredits Institute of Engineers Sri Lanka to evaluate in a particular format the engineering degrees that are offered in the country. And if that accreditation comes, if they say it's okay with the attributes, they say, okay, you're kind of with the, you're okay with the, or you have the Washington Accords accreditation, and ISL passes that. And that means you are kind of like, you have the mobility to move around the world. So our department plus all the others, most of the others have the Washington Accord, the ISL accreditation. Right now, actually, we are setting up for the re-evaluation, maybe like in January. We are setting up our department again for the re-evaluation. But one thing I should add is we were a department that was also accredited by Institute of Chemical Engineers UK. We became the first in Sri Lanka to do that. Of course, there are only 2 departments in chemical engineering, but we became the first to be accredited by IChemE, our BSc program. That's a more of a very professional, very specific and chemical engineering oriented accreditation, because IChemE is the organization. Washington Accord looks at a little bit more in a holistic sense, not very specific about a particular field. They look at you as an engineer, but not as either chemical or electrical engineer. Of course, they take the program attributes, but your approach is different. So we have been accredited by the IChemE. We have not renewed that accreditation, not because the standard scenario, but because of lack of finances to continue with that. But we hope to again enter into that process. So we have been both, we are in Washington Accord as well as the IChemE, so our department.
Thank you very much, sir. Now I would again like to go to the audience. If the audience has any questions, I remind you once again, this is your chance. Please get the maximum out of this opportunity. You can unmute your mic and ask a question directly if you haven't already posted your question. Yes,
So
there's a question.
I have one more question. I've heard that some of the engineering students get to work in management when they go to the industry, instead of, like, it's the idea I have, like, some say that they have to work in management instead of engineering. So my question is, after completing a 4-year degree in engineering, like, if we have to go into management, is it worth spending 4 years learning engineering? Is it clear to you all?
Yes.
There is a chartered financial analyst, so it's the best.
The answer would be like this. even if you do engineering and go into the management, there is an advantage because I have associated people from the commerce background. I'm not asking for you guys to do management, right? I'm just telling I have associated people from the commerce management background and people from the mathematical backgrounds at the management level. So the thinking process that you get from this degree is totally different. The analytical skills that you develop when solving problems, when finding solutions at the engineering scales is totally different. That is why even Ajith sir in the introductory speech said the pioneers in management are engineers. Even if you look at the current modern giants of the management, they are engineers because their thinking is totally different to the thinking of the people from the commerce stream. That is why they have a high amount of value. So if you look at the current Sri Lankan context, even in the finance, even in the hardcore finance in Sri Lanka, it is led by engineers, mainly not even chemical engineers. There are civil engineers, computer science engineers, electronic engineers. So if you have the passion to be a management accountant or something related to that, that's up to you. But if you like to be a chemical engineer, there are opportunities to be a chemical engineer. That doesn't mean if you like to be a chemical engineer, you have to do a management job. Because some people come and say they would like to do a mixture of management and chemical engineering. So if they are trying to be such a personality, so there is opportunity too. So I think even after doing engineering degree, even if you go into the management field, you can be a superstar.
Interestingly, as Susiri mentioned, yeah, engineering gives you some analytical skills, and that's very, very important because you are supposed to be troubleshooting. You approach a problem very differently. You try to understand it, look at all sorts of ways, pathways, and come up with creative solutions. And sometimes from the other fields, that's not going to happen. When I say that traditional management may try to follow an approach, So, and incidentally, it's very interesting. One of the largest economies today and one of the probably one of the most interesting economies that China is run by a chemical engineer. So Xi Jinping is a chemical engineer.
Yes, sir.
Thank you, sir.
So I think we are close to the end of today's session. So we have one question. Yes, sure. Go ahead.
So I want to know, like, if a chemical engineer has an opportunity to learn another language, what would be your first pick?
Well, I think it's our department, one of our members of staff who is teaching Chinese to the university. And we have also I think Japanese, I mean, to my mind, the immediate one comes is Chinese. So learning Mandarin may not be a bad idea.
Yeah, sure. Thank you, sir.
Considering the current situation of the country, yes, also, sir, Mandarin would not be a bad idea.
Yeah.
And I think another main question, one of the final questions that we had was regarding the events of our department. I think Costa sir could just give a small introduction to what are the events that happen in our department.
Actually, we have multiple of events happening at our department. One is the Padura. I think the 18th batch organized the last Padura, and of course the 19th batch will organize the next Padura. So that is one entertainment event. So the next event would be there is something called the Chemicon, where you can present your research findings, your training, learning experiences to the corporate world as well as to the academia. So you are given the platform there, even in the Chemicon. So earlier we had something called the Compass at VMICH, which was the National Chemical Engineering Conference. So you guys can do marvelous things there. At the same time, there are some other events where the interbatch sports events. So there are different fun events happening, as well as there are some other professional development programs like 361 Katabaha, which are oriented to develop the personalities and the skills of the undergraduates. So both the fun events, the events related to create some creativity, entertainment, there are events related to that. There are sports fiestas. Earlier years, actually this year it's all jumbled because of Corona. But if not, there are sports events and various other interacting activities. At the same time, there are professionally developing activities and events happening at the department.
Thank you very much for your answer, sir. I hope that answer was useful to the participants who posted that question on the chat. So I think we are very close to ending today's proceedings. So I have one final question to wind up today's session with. So, both of you all, I'm addressing this question to both of you. Imagine a student comes in without a clear idea, without a direct passion for anything. He's open to ideas, and he's okay with choosing any field. Why would you recommend chemical and process engineering as a suitable option for him?
I'll go first.
Yes, sure.
Yes.
Today we have a seriously an emerging problem, quite a number of problems emerging in the world. One is water, one is food, and the one is climate, and another kind of energy. And these are also interconnected. If we use the wrong forms of energy, we have a problem in the climate. And if you have a problem in the climate, we will have a problem in the food. If you have the wrong direction from the climate, we will have problems with water. So they are very much interconnected. And it's very interesting. That's why we keep on saying in the roadmap of 21st century in chemical engineering, you can look at it from the issue from UK. We say our learning and our abilities have this we have the ability, we trained our graduates with those abilities to have a meaningful contribution to the society in these emerging, to meet the emerging challenges. And if you are a student who want to help the world, who want to solve problems, and you want to be proactive in responding to issues and to make use of your learning for the betterment of the society, chemical engineering is definitely a way to go.
Thank you, sir.
Just to add to that, actually, I would like to share a little my personal experience. Actually, Anushan also shared. We both had the opportunity of selecting any field. So we had enough marks there. So we would have gone to any field. But still, the chemical and processing engineering, it gives you the opportunity to be anyone you want. It has the opportunity to learn different avenues. It is not very strict field. So you can be, if you need to be a polymer engineer, so if you're interested in polymer and the plastic, you can be such an engineer. So at the same time, even if you don't have an idea, one thing I would suggest at this point is, some would have ideas to be an electronic engineer. So if you have that passion to be an electronic engineer, be the electronic engineer. But if you don't have any idea, just look at the scope of the things you can do. And the thing is, half of the, not half, majority of the responsibility of getting good results, getting into the good grades, doing a good research, doing a good design, everything relies on your shoulders. It's your responsibility. So if you come to this department, we will surely support for everything. I think this is one of the most friendly staff in the university. So we are ever ready to support you guys to grow up. At the same time, you need to put your passion out there. So if you are passionate, at the point you select the field, after you select the field, at this time you can compare all the fields, you can compare the salaries, you can compare the opportunities. And if you come to the conclusion of being a chemical engineer, put your passion, you will be a superstar in the industry if you have that passion.
Thank you, sir. Thank you, both of you, Ajith sir, Costa sir, for joining us today. And I think this session will be a very great use for the participants who are going to have a critical decision to go through. And so I hope this session would have been extremely useful for them. And just like you all said, this is a decision that will be made by them. All we are doing is giving them information to help make them that decision, because a well-informed decision should be made, especially regarding something such as critical as this that will decide your career and your future. On that note, I would also like to mention that the Electrical Engineering Department is also organizing a Zoom session later today at 7 p.m. And please join that as well. And you all can join that, and your friends can join that. Please get a good understanding, get a good idea of what the departments are, get a good idea of the scope, and please gain an understanding of who you are and what you want to be. So I hope that we have helped you in that regard. I hope that we have given you information and advice and shared our experiences with us. I should again very specially thank both all three of our speakers, Ajith sir, Costa sir, Anushan sir. They have very busy schedules. They are very busy people in the industry, in academia, and they have all taken their time off just for you, just to help you. This is all just to help you. And we organize this for you. So I'm very thankful for them again. And I should also especially thank my fellow batchmates of the 18 batch who got together a few days ago and had the idea to participate, to organize the session for y'all. And I should give my very special thanks to them for pulling this off at short notice. And I think it was a very successful initiative and something very relevant. And on a final note, I would also like to thank the 19 batch and everyone who joined today's session. I really hope that you all got something out of this. I really hope that, and I love to see you all interacting. Everyone was posting questions on the chat. People spoke up in the meeting. And even though might not have been able to answer all your questions, I think we managed to do justice to most of your questions. And I think it was in all, it was a very fruitful session. So on that note, I would like to conclude today's proceedings. Thank you very much to the speakers. Thank you very much to the participants. I hope you all stay safe in this context. Everyone, please stay safe, wear a mask, wash your hands, and follow. Everyone, just generally be safe. And until a fellow chemical engineer in the forefront for the COVID-19 vaccine discovers it, we'll all need to take a little special care of ourselves until then. And I'm glad to see so many participants here today. I really hope, I will be really happy to see some of your faces at the Department of Chemical and Process Engineering in the future. On that note, I would like to conclude this session. Thank you very much, everyone. Have a good night, and thank you again.
Thank you, Dinendra.
Thank you.
You're welcome, sir. Thank you, sir, again.
Mm-hmm.